Okay, ladies and gentlemen, what we're going to do now is we're going to start integrating products. Now, anytime we differentiate, we have a product rule that allows us to do differentiation. Unfortunately, we don't have any such rule for integrals. Now, in this particular case, I have the integral of x sine x dx. To try to integrate that, I'm going to need to somehow break this up. Well, unfortunately, since there is no product rule, we're going to have to use what's called integration by parts. Now, the standard form for integration by parts is as follows. It is the integral of u dv equals u times v minus the integral of v du. Now, as in the product rule, we have u prime v plus v prime u. We let u and v represent various quantities that we determine. In the same way with integrals, we're going to have to somehow break this up into renamed quantities, and those renamed quantities are going to be u and dv. Now, obviously, anytime we have a dv and we're going to need a v, I'm going to have something over here with the dx component of our integral in it, because I'm going to need to get rid of dx at some point. That's the whole point of the integral. Now, what goes along with that can vary. I could do one of two things in this problem. I could either say u equals sine x, because that seems to be a part of something, and x as x dx is dv. Alternatively, or I could say u equals x and dv equals sine x dx. Those are pretty much the two ways I have to break up the components of this particular integral. Now, the challenge is, our whole point is to try to get this thing integrated. Well, if I attempt to use u as sine x and dv as x, I'm going to need a differentiation, a du. So to find du, that's going to be cosine x dx. If I need a v, that means I need to integrate this side. V is going to equal 1/2 x squared plus c. Now, the whole point of this pattern is to integrate something that we can't otherwise integrate, just like differentiation. Use that pattern for a product rule. So we're going to say u times v, and so that's going to be sine x times 1/2 x squared plus c. Now, plus c we can tack on at the end. So that's u times v. Then it says minus, so if I go back this way, put a minus sign in, v du. Well, v is the integration of 1/2 x squared and cosine x dx. Now, the problem is when I do this particular uv minus the integration of v du, this is good, but this is worse than what I had to begin with. So when we're choosing what to do, we need to be careful to choose wisely. In this case, this is not a wisely chosen u and v. Let's go over here and see what happens. In this case, I have u, so du equals 1 dx. V equals sine x dx, so v equals negative cosine x plus c, because when we're integrating sine x, we're going to get a negative cosine x. Now, when we attempt to do this, u times v, we're going to get x times negative cosine x, and then the plus c we can tack onto the end, minus the integration of v du. Now, if I have the minus the integration of, so minus there, v du, well, v is negative cosine x, and the du is nothing more than 1 dx. Well, the nice thing is, at this point, I can simplify the following to two negatives, make a plus, integrate cosine x dx, and whatever the integration of cosine x is, which happens to be sine x plus c. So I end up with something here that I can integrate. That is the entire goal, is to be able to integrate this by breaking it into parts that when we get done, we can integrate and come up with the actual product. So that is the first integration by parts. So that's the first integral of a product. We're going to do a couple others, so stay tuned.